AJMAL, and I'm going to talk about sustainability and the relation to fermentation technology. Sustainability is the capacity to endure. In a more general scientific sense, sustainability is equivalent to continuum or the ability to continue a course without termination. Therefore, sustainability is compatible with the existence of the universe, and it is the ability to maintain a definite stable outcome. It refers to processes, objects, or matter, and is incompatible with monotonous increase or decrease of amount of matter. Let's say, for example, the monotonous increase of the amount of trees used leads to the exhaustion of the limited surroundings containing the trees, or the depletion of the sources that provides the trees, in this case are lands. While a monotonous decrease of the amount of matter, let's say fuels, leads to the eventual exhaustion of the fuel. The most widely quoted definition of sustainability and sustainable development, which came from the Brundtland Commission in 1987, sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Sustainable fermentation is a framework that focuses on applying minimum criteria or specific methodologies. As much as possible, assessment should be carried out on life cycle basis, starting from biomass feedstock and extending to the end of life of the product derived from its biomass feedstock, obeying the key issues in 4 areas of sustainability: economic, environmental, social, and good governance. In fermentation technology, the main objective of it is to create a successful fermentation with cost-effective process without sacrificing the quality and yield of the product. Thus, the top-to-bottom process must be economic. In a fermentation, the raw materials are often the crucial part in maintaining operating costs at minimum level, in which the terms of pricing and availability plays a major role. From supplier to producer to consumer chain, it is important to apply a fair and honest trade along the value chain to prolong the long-term viability and competitiveness. Thus, it is important to establish an infrastructure and logistics for supply and distribution. Cause and effect of an action has always been reviewed in environmental impact, as the definition of sustainability states the prevention of exhaustion for future needs, which leads to be the thinking process of avoiding resource depletion, such as conservation of water quality and quantity that should not be taken for granted. Another example is the exploration of new lands, and the efficiency usage of the lands must not be let to waste, as the ecosystem resilience is somewhat delicate due to the biodiversity of multiple habitat that exists in an ecosystem. That should not be tempered, as balance is important, and the existence of fermentation technology is the key to pursue a sustainable bioeconomy. So, how to relate sustainability to fermentation technology? In fermentation technology, we study the methods in production of desired product and tries to maximize the current production. Along the way, we have to maintain the balance in ecosystem. What material we use, what process, condition does our method affect the environment? All of this needs to be considered, as Earth have limited resources. Prevention of exhaustion of matter is crucial for future generation. It may not run out now, but it will eventually. So in fermentation technology, we pursue the ideal fermentation where there is no such thing as waste in the process, where all the fermentation of product and byproduct can be used in other applications. In this way, we can sustain the limited resources of our Earth.
Assalamualaikum, I am NADHIRAH binti ZAINORDIN. Today I am going to introduce the sustainable product fermentation, which is the ethanol. The ethanol is an organic compound or ethyl alcohol, and it can be synthesized by the variety of foods. And usually for the bioethanol, it is being produced by the utilization of sugar and starch by the microorganisms. The microorganism that can be used is the Saccharomyces cerevisiae or Zymomonas mobilis. Here are the chemical equation for the production of ethanol. So for the 1 mole of the glucose will be produced 2 mole of ethanol with 2 mole of carbon dioxide and 2 mole of water with the energy. Here are the some of the for the production of the ethanol comes from the various pathway according to the type of cell that being used. So for the Saccharomyces cerevisiae, the pathway is the glycolytic pathway. The sugar is hydrolyzed to glucose and fructose by the enzyme invertase. Here it can be seen the pathway from the glucose. Glucose will be broken down to simpler compound to produce the fructose, and the glucose and the fructose then will be utilized and taken up by the cells and going to this glycolytic pathway to release ethanol as the byproducts. Here the cells also release minor products such as the acetic and the lactic acid. So for the ethanol feedstock, it can come from the various sources. Here we focus on the sugarcane. The ethanol feedstock can come from the sugarcane itself, the molasses, and also the bagasse. The sugar juice from the sugarcane is being extracted by the squeezing or diffusion method, and after that the sugar juice will be utilized by the microorganism, and some can be the recombinant microorganism to produce the ethanol. And currently the newest approach is the application of the lignocellulosic feedstocks, which is the bagasse, for the production of the bioethanol. Here are some projections from the research from Dovko, Nur and Walker. Here are the world biodiesel and the ethanol historical production and projection. This research has been done during 2008. Here can be seen the production of ethanol is increasing throughout the years, and the production can be reached up to 45 billion of gallons of ethanol that is being produced. And for the industrial biofuel production of ethanol can be divided by three current routes, which is the first is the biochemical, the second is the thermochemical, and the third is the hybrid route. The biochemical consists of 2 steps. The first step is the hydrolysis, and the second is the yeast fermentation. For the thermochemical is the conversion of the biomass via gasification that will be followed by the mixed alcohol catalytic synthesis. For the hybrid route is the combination of the method above. With the first, it will be hydrolyzed. It will be for the combination of the above method. The first is the gasification process, and secondly is the yeast fermentation. So for the bioethanol process production by the syngas fermentation, this is the upstream processing. The upstream processing consists of 4 steps, which the first is the bagasse pre-treatment by the drying and crushing. Second is the gasification. Third is the syngas conditioning, and the fourth is the syngas fermentation. So for the first pre-treatment, the bagasse will be dried and then will be crushed to smaller particles with the gyratory crusher to the size of 2 mm. For the drying process, the bagasse will be reduced to moisture content about 10%, and then this will be supplied. The bagasse will be supplied with the oxygen will be supplied with the oxygen by entering the reactor, and the supply of the oxygen comes from the ASU. ASU is the air separation unit. This air separation unit will be allow only oxygen that flow through the gasifier. And the next process involves the two cyclones. The first one separates the unreacted char from the producer gas and recycles it to the gasifier. Meanwhile, the second one will remove the ash from the gas mixture. Then the catalytic conversion of light hydrocarbon to syngas is occur in the catalytic reformer with the 1073 Kelvin with the 1.7 megapascal operation. This process then continued with the cooling down the hot gases by using the heat exchanger to a final temperature of 323 Kelvin. And the fourth step is the SYNGAS fermentation. This is where the yeast fermentation is occur. This process involves the metabolism of microorganisms to produce the ethanol, and the operation occurs at 311 Kelvin at the pressure of 0.15 megapascal. The reactor used is the CSTR. And the next process, the function in this section is the cells. After in this process of ligand, after distillation, the aqueous probe with dilute acetic acid is recycled back to the inlet of the fermenter to reach the equilibrium condition and constant concentration. Meanwhile, the cell is centrifuged and also recycles back to the bioreactor. The flush drum separator is used for the separation of unreacted gases from the liquid products that contained in the fermenter probe. The gas then recycled back to the bioreactor, but with a portion of 80% only to avoid the accumulation of gas in the bioreactor. Meanwhile, the other 20% will be supplied to the CHP. To increase the electricity that it is equal to the 25.5 megawatt. And the last process is the purification process. This will be discussed by ISFAHMI. That's all for me. Thank
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ISFAHMI bin Muhammad JAMIL, and today I will talk about downstream processing and its importance. So basically, what is downstream processing? Downstream processing is referring to the process of recovery and purification of bioproducts. It involves different unit operations such as distillation, chromatography, centrifugation, and more. So, why is downstream bioprocessing important? This is because in the downstream processing, this is the process where we want to recover our product before we can commercialize it, purify it, and use it for any other purpose. So that's why downstream processing is important. It's also the process where we can know whether our production process has successfully gotten us what we need in the end. So downstream processing is one of the most important components in the production and development of a product. So I will talk more about the downstream processing in details. I will talk about the downstream processing of bioethanol. So generally, bioethanol can be produced via several methods, whether using carbohydrate fermentation or syngas fermentation. But it doesn't matter what method that we are using in producing bioethanol, the downstream processing is generally the same for every method that is used for production of bioethanol. The generally used method in downstream processing of bioethanol is the distillation process. Other than that, there are also different unit operations that have been tested in downstream processing of bioethanol, such as adsorption column, membrane separation, and also distillation column. However, the distillation column is the most popular and conventional method in downstream processing of bioethanol. So I will talk more on how distillation process is conducted in the downstream processing of bioethanol. So basically, after the fermentation process ended, the liquid fermentation product, which is the fermentation broth, will enter a series of two distillation columns, which give as output distillate with 95% of ethanol and water mixture. This water and ethanol mixture is also known as azeotrope. Then the mixture is fed to an extractive distillation unit that comprises of two more distillation columns, the extractive distillation 1 and the solvent recovery unit, where the entrainer is obtained. The entrainer is a substance which forms a separate phase and is a specific component of industrial azeotropic distillation method. So, the entrainer used in this process should be non-volatile and have a high boiling point, and essentially does not form any azeotrope with either component of the original azeotropic mixture. So, the entrainer that is used in this distillation process is ethylene glycol. So I mentioned just now that the azeotrope mixture enters two more distillation column. So the distillate of the first column is pure ethanol, and the bottom stream is the mixture of water and the entrainer. The mixture of water and the entrainer is sent to the second column, where ethylene glycol, which is the entrainer, is recovered from the bottom and is returned to the extractive column. So finally, pure bioethanol will be successfully purified. Okay. So this method of distillation is also known as extractive distillation because it includes an extractive distillation unit in the whole distillation process. This extractive distillation has more advantage compared to the common distillation process, or also known as azeotropic distillation, because in extractive distillation it requires a lower amount of entrainer, which leads to lower energy consumption and low capital cost because the lower volume of the distillation units. So, according to a study, when we choose the method to produce bioethanol, it will significantly affect the downstream processing, because the downstream processing is also part of the production cost. So it is wise to choose a production cost that requires the minimum cost as low as possible, because by then the downstream processing cost will also be low. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is SHAHRIL, and today I will talk about the importance on sustainable fermentation product. So our tea product is by production of ethanol. So ethanol is a fuel of the future as a gasoline replacement. Hence, it's important on sustainable fermentation on production of ethanol. The ethanol production is using a fermentation and distillation technique from sugar. However, now the production is producing from corn grain. The one of the important on this production is enzyme that produced by organism for break down glucose. Enzymes are produced on an industrial scale using genetically modified organisms and are an important part of commercial ethanol production from non-sugar feedstocks. Hence, improvement in process economics using new design cellulose enzyme cocktail are important factors in establishing a cost-effective technology. Corn is approximately half grain and half residual, where only 1% of the plant is sugar and can be directly fermented. However, about 72% of the plant consists of sugar-based polymer that have the potential to ferment. Saccharification is a process where starch is easy to compose using enzyme. Unfortunately, the cornstarch replacement for methyl tertiary butyl ether, or we call it MTBE, in reformulated gasoline. It has the potential to play a much more important role in fueling the nation. Change in production method and feedstock for ethanol are necessary for it to become serious replacement for gasoline. Grain ethanol consumes 10% of the current US corn grain production but only account for 2.6% of the total US gasoline supply. The fuel that is produced may have slight positive environmental impact and significantly positive impact on domestic energy independence. But the resource supply is not large enough. Lignocellulose biomass hold the promise of greatly expanding an ethanol feedstock resource, but it remains to be seen whether this promise can be translated into industrial processes that actually perform in globally sustainable, domestically energy-producing manner. Hence, sustainability is not about making fuel last forever, it's about making it last long enough that future generation will be around to replace it. Using fuel ethanol is a step in the right direction. There is other alternative that can be used, which is corn grain is why corn grain is limited available to produce ethanol. The other feedstock that can be used is sugarcane, which about 7% sugar, but when it's dry, it's about 50% sugar content. However, sugarcane can't grow well in colder climate for some countries. Some countries like US growing sugar crop for fuel production is probably too expensive to be practical. Another is a paper is a primary constituent molecule waste. Converting this fuel will be save less space. Moreover, this material has a similar theoretical ethanol yield to corn grain. And that's all for me. Thank you.